Hello everyone. I'm Zareen Subha from Team DroneSense, and along with my teammates, I'll be presenting our project DroneSense. Our project focuses on smarter and more sustainable air quality monitoring using autonomous drone technology. We wanted to create a solution that moves beyond fixed monitoring stations to collect real time, location based data efficiently and responsibly. DroneSense is a modular drone platform combining air quality sensors, a self charging dock, and cloud analytics, making data collection faster, more flexible, and cost effective. Here you can see how DroneSense works. It gathers live data on key pollutants like PM2.5, carbon dioxide, and nitrogen dioxide, providing accurate insights for councils and environmental regulators. By automating this process, it reduces manual work and promotes long term sustainability. Moving on to our statement of work. This project's purpose is to develop a reliable modular UAV system for urban air quality monitoring. The scope includes sensor integration, an autonomous charging dock, a cloud data system, and full regulatory compliance. We have excluded large scale production to keep this phase focused on only proof of concept. Our goals are real time, data accuracy, weather resilient performance, and actionable results for our stakeholders. Next, our assumptions follow CASA drone rules. Flights under 120 meters within visual line of sight and in approved test zones. We assume moderate weather and use of Australian cost estimates over a 5-year period. All flights require permits and project risks are tracked weekly to stay within safety and compliance standards. For our recommendations, we'll start with the pilot phase to test and calibrate sensor accuracy, then a compliance phase to ensure full CASA alignment. Next, the improvement phase will include refining docking reliability and weatherproofing. We'll also run community engagement sessions to manage privacy and noise concerns. And finally, set up data quality standards for integration with national air monitoring frameworks. Lastly, our responsibility matrix outlines clear roles. Bilal leads as project manager, Jake handles ESG, Amitesh and Kunya manages scheduling, Bravis oversees risk management, Hui ensures compliance, I handle recommendations and adoption planning, and Yichi maintains governance and communication. In summary, DroneSense combines engineering and sustainability, delivering a practical, data driven system to help cities monitor air quality more effectively and responsibly. Thank you. Now I'll be passing over to Amitesh to talk about time estimation.
Our team used an activity on arrow network diagram to estimate the total duration of the DroneSense project. Based on the listed activity durations, we determined the total project duration to be 18 weeks. The critical path is marked in red on the network diagram and includes key activities. These tasks determine the minimum time required to complete the project, as any delays on this path will directly extend the overall duration. Non-critical activities have limited float times, providing us with some scheduling flexibility. Establishing these dependencies allowed us to logically sequence work, balance the team's workload, and set realistic milestone checkpoints within the 18-week timeline. The graph shows the planned value curve for the DroneSense project. This curve is plotted based on time estimates and monthly resource plans in the table. The curve shows that planning and procurement expenditures are low in the initial weeks of the project, then rise rapidly during hardware integration and testing, and finally plateau as the reporting and validation work is completed. This S-shaped PV trend represents the cumulative budgeted cost of scheduled work, serving as benchmark for tracking future performance. Weekly progress reports are submitted, with each team member recording their percentage of completion, updating the shared Gantt chart, and reporting at milestone meetings. The project manager then summarizes these updates, comparing actual progress to the PV benchmark to ensure the project consistently meets schedule and cost expectations. Therefore, time estimates define when work should begin, while the planned value graph defines how much progress should be made over a given period. Together, they form the foundation for effectively monitoring and delivering DroneSense on time.
Hello, I'm Bilal and I'll be going over the cost breakdown. We started by benchmarking existing commercial products to get an order of magnitude figure. Systems like the DJI Mavic 3 Enterprise, Purple Air sensors, and Haisha self-charging docking gave us a baseline of around 40,000 AUD. We then verified this bottom-up using current Australian retail prices and inter-labor rates with a 25% overhead and a 15% contingency. Altogether, our total project cost comes to around 41,000 AUD. As shown in the pie chart, labor accounts for roughly two-thirds of the budget, followed by hardware, contingency, and a small share for operations and OPEX. Breaking that down, labor is the main cost at 27,000 AUD. Hardware, including spares, sits around 7,000, and the remainder covers operations, OPEX, and contingency. The monthly plan shows how spending ramps over the 18-week period. In month 1, most of the spending is hardware procurement. Month 2 to 4 are dominated by integration and testing labor, and month 5 is the wrap up and reporting phase. This stage profile aligns with how the project activity builds up and then winds down. Finally, we ran a short sensitivity analysis. If hardware prices swing plus or minus 20%, total cost only changes by around 1,500 AUD. But if labor hours shift by plus minus 25%, the total moves around by almost 7,000 AUD. So the key takeaway is that labor efficiency is the main cost driver. Hardware prices are relatively stable, and 15% contingency keeps us safely within the expected project budget. In short, staying on schedule and managing team hours will have the greatest impact on cost control.
At DroneSense, we take pride in our sustainable practices across the environment, social, and governance pillars. Environmentally, DroneSense reduces its carbon footprint through lightweight, energy efficient drone designs, solar powered charging pads, and e waste recycling. We align closely with the UN Sustainable Development Goals, particularly SDG 3, 9, and 11, by improving health outcomes, promoting innovation, and supporting sustainable urban development. Socially, we recognize the importance of community acceptance and transparency. We'll share flight schedules, data use policies, and hold public consultations to address privacy and noise concerns. Through partnerships with universities and councils, we'll also promote education, inclusivity, and local employment in drone technology and environmental science. From a governance perspective, DroneSense ensures accountability through dedicated sustainability teams, strict compliance with ISO 27001 and the Australian Privacy Act, and ongoing ESG reporting under frameworks like TCFD and ASRS. In summary, DroneSense integrates innovation with responsibility, delivering cleaner air, stronger communities, and ethical governance for a more sustainable future.
Okay, here is the risk assessment. The heat map shows likelihood racing from bottom to top and impact increasing from left to right. The up right corner tells us our biggest pressure comes from operation, compliance, and security. We rank everything with a simple LI threshold. Those high score items are treated as top priorities. As seen in this slide, we turn those high-risk items into clear actions with a named owner for each one. So everyone knows who's doing what right away. We mix simple tech protection like secured command paths with practical routines like checklists to make risk control to be part of everyday work. This also cuts surprises. We have full back options, sticker schedules, and fewer cost blowouts. Together, these steps lower the leftover risk and help us keep people safe, stay on time, stick to budget, and keep our permission to operate.
So the main challenge for DroneSense was staying on time and within budget. Bringing together hardware, software, and sensor requires strict scheduling, while limited resources and expensive sensor created financial pressure. On top of that, scope change, team coordination, and technical risk meant we had to prioritize carefully to keep the project on track. To manage those challenges, we use these tools to help us stay organized, manage risk, and focus on what matters the most. In summary, DroneSense is more than just a concept. It's a practical and reliable solution. With smart planning and solid technical design, it can deliver wider and more accurate air quality data at a competitive cost, while still meeting safety, compliance, and ESG standards. Most importantly, it shows how innovation can help build healthier communities and a smarter, more sustainable cities. Thank you so much for listening.